Ever wondered how scientists track what kids hear? Like, literally listen to their world. It's trickier than it sounds. Think of speech tracking tools as little audio detectives. But even they can get confused, especially when there's a crowd of voices or a tricky accent. Let's break down what this research uncovered and why it matters. Here's the thing. When studying child language development, researchers rely on tools like VTC and LENA to count vocalizations. Any sound a child makes, that's not background noise. But here's the catch. These systems aren't perfect. They're trained on data dominated by adult voices, so they struggle with kids' speech. Higher-pitched, more variable, and full of squeaks and giggles that confuse the algorithms. It's like trying to read a book in a language you've only heard snippets of. Now here's where things get tricky. The study found that without calibration, VTC and LENA gave wildly different results. For example, VTC underestimated female adult speech by 7%, like a blurry photo where everything's slightly stretched. LENA missed 6% of speech entirely. These tiny errors add up, like a snowball rolling downhill. But how do researchers fix this? The answer lies in Bayesian calibration, a statistical method that adjusts for tool biases. Think of it as a reality check for the tools. By comparing their guesses to manually labeled data, researchers fine-tuned the algorithms, like giving them glasses to see the world more clearly. Here's the process. First, scientists created a gold standard dataset by having humans label hours of audio. Then they compared this to the tool's results. The gaps between human labels and tool outputs revealed where errors occurred. Using Bayesian math, they adjusted for these mistakes, much like fine-tuning a telescope to get a clearer view of the stars. The results? Calibration dramatically improved accuracy. But here's the reality, no solution is perfect. Tools like LENA still struggle with overlapping speech when a parent and child talk at the same time. This makes their calibration less reliable, leading to shaky results. It's like trying to solve a puzzle with missing pieces. And the implications are huge. For instance, the study found kids without siblings hear 67% less input from other children, a gap automated tools missed without calibration. It also showed that the real effect of age on speech isn't just bigger than previously thought. It's stronger because uncalibrated tools masked it by confusing adult and child speech. But there's a catch. Tools trained on North American English data struggle with younger kids and non-English speech. It's like giving a French speaker a Spanish dictionary. Words don't match, and the whole system breaks down. This highlights a critical blind spot. Without diverse training data, tools can't capture the full picture. So what's the takeaway? Calibration helps, but it's not a magic fix. A tool that works in a noisy city classroom might fail in a quiet rural home. And small errors, they can skew big conclusions, like a single wrong note ruining a symphony. But here's the good news. The study found confidence scores, like a built-in truth meter for algorithms. When the tool is sure of itself, the data is more reliable. Think of it as a GPS that says, hey, I'm 90% sure this is the right turn. These scores could help fix errors like a quality check for AI. In the end, this isn't just about tools. It's about understanding the human side of data. Every number tells a story, but only if we listen carefully. And remember, this is just one piece of the puzzle. The next time you hear about speech tech, you'll know there's a whole world of hidden challenges and exciting fixes behind the scenes. Thanks for watching. If you want to dive deeper into how these tools work, check the links below. And remember, science is all about questioning the tools we use. Until next time.